Hey guys, welcome to brainAttic. So today we have another very interesting integral to solve, and this integral was asked in JEE Advanced 2016. Now the best part about this problem is that this question has so many concepts involved in it, and if you take a direct attack in solving this problem, it becomes very complex. But if you use the formulas correctly, it becomes quite easy to solve. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. So what we are going to do is that we are going to first apply the formula integral over a to b f of x dx is equal to integral over a to b f of a plus b minus x. Now if you see, my a is minus pi by 2 and my b is plus pi by 2. So a plus b technically becomes 0. So what I'm going to do is I'm going to simply substitute x with minus x, and this gives me dx is equal to minus dx. Okay, so now my new integral would look something like this. I is equal to integral over minus pi by 2 to pi by 2 minus x whole square cos minus x by 1 plus e power minus x, and this negative dx actually I have adjusted in the limits. So this simplifies to is equal to minus pi by 2 to pi by 2 x square cos x by 1 plus 1 by e power x. This again I can rewrite as minus pi by 2 to pi by 2 x square cos x e power x by 1 plus e power x dx. Correct, right? Now what we are going to do is now we are going to add the original integral which was given to us and the newly found integral. So we have 2I is equal to integral over minus pi by 2 to pi by 2 x square cos x by 1 plus e power x dx plus minus pi by 2 to pi by 2 ex x square cos x by 1 plus e power x dx. The good part here is that it will become minus pi by 2 to pi by 2. We have 1 plus e power x both in the numerator and the denominator now, and the leftover term is x square cos x dx. So we can cancel these two out, and this is what we are left. 2I is equal to minus pi by 2 to plus pi by 2 x square cos x dx. Now if you observe closely, right, this expression is a even function. How it is an even function is that if you substitute x with minus x, you see that x square remains as x square and cos x remains as cos x, cos of minus x, and it remains as cos of x. So this expression is therefore a even function. So again I'll use the property of definite integrals, and I can write that 2I is equal to 2 integral over 0 to pi by 2 x square cos x dx. Okay, so now my final integral looks like I is equal to 0 to pi by 2 x square cos x dx. Now there is a straight approach to this, and we have to use integration by parts. Integration by parts. So those of you who are not familiar with the formula, it is something like integral over u dv is equal to u v minus integral over v du. Okay, so this is how the formula goes. So my u can be x square. Since I'm trying to solve for this, u can be x square, then dv is equal to cos x dx, and du will become 2x dx, and v is sine of x. So if I apply this, my integral I will look like integral x square sine x over 0 to pi by 2 minus integral over 0 to pi by 2 2x sine of x dx. So let's first solve the first part of the expression. We'll look into the second part a little later. So we have pi by 2 whole square sine pi by 2 minus 0. Okay, and what we have in the second part is 0 to pi by 2 2x sine x dx. Correct? So my final integral now looks like pi square by 4, because pi by 2 is basically 1, minus 2 over integral 0 to pi by 2 x sine x dx. So I'm going to use the same integration by parts again. So here what I'm going to do, my u is equal to x and my dv is equal to sine x dx, correct? And my du is basically dx and my v becomes minus cos of x. Okay, so my integral now will look like 0 to pi by 2 x sine x dx is basically nothing but minus x cos x integral over 0 to pi by 2 minus integral over 0 to pi by 2 minus cos x dx, correct? So this basically comes out to be 0 minus 0 plus sine x integral, limits are 0 to pi by 2, which is 1 minus of 0, finally 1. So my final answer for the integral is basically pi square by 4 minus 2 into 1, which is nothing but pi square by 4 minus 2. So this is my answer for integral I. So if you do like the video, hit the like button and subscribe to our channel for more content like this. Thank you so much for watching.